This is Changing Denver, the show about our city, how we make it, and how it makes us. I'm Paul Caroli. In 1998, a respected medical journal in the UK published an article depicting a set of experiments and a conclusion. The conclusion in this case being that certain vaccines have a causal relationship with autism. Although the journal later retracted the article and renounced its conclusion, the damage was done. Tens, and then hundreds, and then thousands of people believed it. They saw their children get vaccinated and then suffer from autism. This study diverted their fears and anxieties into much more comfortable emotions, anger, and self-righteousness. And slowly, as more and more people opted not to get their kids vaccinated, measles returned to England. The anti-vax movement kept spreading, and measles returned to America. You might be asking yourself at this point, why the heck am I hearing about anti-vaxxers in this podcast about Rocky Flats? What does any of this have to do with a former nuclear weapons plant being open to the public as a wildlife refuge? Well, the answer is perspective. In the first 3 chapters of this series on Rocky Flats, you've heard me speculate on the implications of the activists' claims. If the refuge is as dangerous as they insist it is, what does that say about the regulatory agencies? What does that say about the people who run our government?
They're being paid to go along with the groupthink and the party line and persuade the public that there's no danger and just trust us, we're the government. That's not good enough.
But what if Harvey Nichols and the other activists are wrong? What if the refuge is safe? What are the implications of that? Then those same activists start to sound a lot like anti-vaxxers, don't they?
There's really no way to explain that he has heart cancer other than the plutonium. It's too rare. It's too rare of a cancer.
They argue on behalf of children's safety.
I have grandkids, I have great-grandkids, and when I think about a child going out there, we want them to grow up healthy and thrive. We don't want them to have leukemia.
And just like the anti-vaxxers, they divert their fears and anxieties into much more comfortable emotional spaces.
I suspect there may be a conspiracy of some kind.
Don't bother your pretty little head. There's no risk here.
I think follow the money. Follow the money.
But then again, what if they're right? There are things in this world that have no inherent truth. There are gray areas. There is subjectivity. But we're not brains in vats. We all feel the same hard ground beneath our feet. We all feel the same tug of gravity at the height of a great leap. There are facts. There is science. And that's what today's episode is about. In this hotly contested issue, freighted with decades of history and emotion, there is an answer to the central question. Presented in partnership with the Colorado Independent and the Denver Public Library, Changing Denver presents Unclear Danger, the Colorado story of Rocky Flats. Chapter 4. Is it safe? All right, I guess first things first. Could you introduce yourself to me the way you'd want to be introduced on the radio?
I'm Carl Spring. I'm with the Colorado Department of Public Health and Environment, and for the past about 25 years have been a project manager for the state at Rocky Flats.
Carl started his career as a geologist, but after a downturn in the oil and gas industry in the early 90s, he joined the public sector and became the state of Colorado's point person for all things Rocky Flats.
Had you heard about Rocky Flats before?
I had, but like most citizens, had never set foot on it. I was unaware of exactly what its purpose was. I knew it was very secretive, very secure, and it lit up the sky in the night. From miles away, you could see Rocky Flats.
Carl is a stocky man, with a well-trimmed gray mustache and a lanyard hanging around his neck. A few months ago, I sat across from him in a drab conference room, deep in the bowels of the CDPHE headquarters in Cherry Creek. The lights were fluorescent, the chairs were uncomfortable, the wall hangings were somewhat inspirational.
So it was just like, that was all it was to you? It was just a secretive site somewhere?
It really was, yes.
For 25 years, Rocky Flats truth seekers have made their way to Carl, to conversations like this one. Whatever their reasons, the questions are always the same.
What is the current condition of the site? What are the risks to a refuge visitor? Is there off-site contamination related to the Rocky Flats site? Does it pose a risk?
Carl and his team eventually wrote down their stock answers to all these questions. Now, if you go to the Rocky Flats section of the CDPHE's website, you'll find an FAQ with very carefully phrased entries replete with charts and links to sources.
Where does the CDPHE get funding for its Rocky Flats oversight? The U.S. Department of Energy reimburses CDPHE for its Rocky Flats remedy oversight, environmental fees, and associated costs, e.g. sampling. In accordance with the terms of the Rocky Flats Legacy Management Agreement, CDPHE's billable hours and other costs are charged to a specific grant. This is an example of the polluter pays principle of environmental law, where the responsible
It's simple and tidy and neat, and I'm sure you'll agree, not at all reassuring. That's why I wanted to talk to Carl. Even the most detailed and rigorous FAQ isn't good enough for me. I need to hear a person's voice to understand where they're coming from and how they feel about Rocky Flats.
One of my sons has been there. Even have a grandson that went out and helped collect seeds on the site that can be reused or have been reused on the site. I have a collection of pictures from the site that are just absolutely beautiful and reminds me why making that a wildlife refuge was such a good idea.
Carl feels comfortable bringing his grandkid to the wildlife refuge because he trusts that the 10-year, $7 billion cleanup was effective. More than 800 structures were decontaminated and demolished, more than 360 specific sites of contamination were remediated, and more than 500,000 cubic meters of radioactive waste was shipped to disposal sites outside the state. And when we evaluate the safety of the site, what we're really doing is evaluating these actions and the thinking that led to them.
And this gets very complicated very fast. As simply as I can explain it is that risk is the risk of excess cancer. We all have a risk in the United States of contracting cancer in our lifetime. It's approximately 40%, a little higher for men, a little lower for women. But on top of that 40%, we want to know what the excess cancer risk might be of coming into contact with contaminants at a site, Rocky Flats, for instance.
Sites like Rocky Flats have a government-mandated range of allowable excess risk.
That risk range of acceptable risk in statute is 1 in 10,000 to 1 in a million. If the risk is greater than 1 in 10,000, it's unacceptable and action has to be taken. If it's less than 1 in a million, it's considered negligible.
Remember back in Chapter 2 of this series, when we told the story of Leroy Moore and the activists pushing back against the initial cleanup proposal? The regulatory agencies proposed a series of radionuclide soil action levels, or levels at which remediation action would be required. The activists and local governments said no, those levels are too high. The regulatory agencies eventually compromised and set much lower levels. Specifically, they pledged to remediate any area of the top 3 feet of soil where there was more than 50 picocuries per gram of plutonium.
When that was applied then, at Rocky Flats, this 50 picocuries, everywhere that 50 picocuries or greater was measured, that soil was excavated and hauled off site, out of state. What you ended up then once you took these areas that exceeded the 50 picocurie action level, then the average left at the site within the central core area that is retained by the Department of Energy, the average there is about 2.3 picocuries, trillionths of a curie per gram. The surrounding area that's now part of the refuge is only 1.1 picocuries per gram. Both of those well below any levels of concern.
Levels of concern, can you put that in terms of the 1 in 10,000 or 1 in 1 million?
Well below those levels for either a wildlife refuge worker or a visitor.
This is what the regulators remember about the cleanup fight. They chose conservative action levels, submitted to even more conservative action levels, and then found that the actual amount of contamination was much lower than they even anticipated. Minus a few hotspots in the central operable unit.
So, I think it might help to give an example of how all those numbers would affect just a person. If a person walked in through the wildlife refuge, through the central operable unit, what are the chances that...
Well, there's a couple things that will add some perspective to that. First of all, we're talking about millirems, thousandths of a rem.
A rem is a standard measurement for a dose of radiation.
We see in studies, we see and can determine that about 1,000 rems leads to death. That's a fatal dose. About 100 rems, we see negative reactions. So we have lots of data to determine that.
When he says we have lots of data to determine that, the we is not just the CDPHE. Those numbers are widely agreed to by numerous sources. The International Atomic Energy Agency, the World Nuclear Association. It's fair to call it a consensus.
These are REM levels we're dealing with in our standards and exposures that we see at Rocky Flats with millirems, thousandths of a rem.
And then in terms of millirems, walking through the refuge right now and walking through the central operable unit.
Be a fraction of a millirem.
A fraction of a millirem.
Yes.
There's another thing about Carl Sprang you should know. He's getting ready to retire. When I went in for this interview, he had his protege, Lindsay Masters, sit in. After about an hour of talking about millirems and picocuries and dosimetry and epidemiology, I think she could tell I was drowning in all the numbers. She asked if I wanted to see a different way of thinking about radiation, and I gratefully accepted. We said goodbye to Carl and went to her office. She woke up her PC, and I fumbled to get my recorder back on.
This is the United States Nuclear Regulatory Commission's personal annual radiation dose calculator. It lets you figure out approximately how much radiation you are exposed to on an annual basis. Mm-hmm. It takes into account things like where you live, what you eat, drink, and breathe, other sources. And then
I recommend pulling up this calculator at home and testing yourself. You can find it at www.nrc.gov.
So, in this case, you and I live in Colorado. We're at altitude, so we get a little more radiation. Between 5,000 and 6,000 feet, you get 29 millirems per year from that. Mm-hmm. Also, the Colorado Plateau area and areas with naturally occurring uranium and other radionuclides from degradation in the rocks give you an exposure. So uranium creates radon, which is something of a health issue here in Colorado, and you can get a dose from that. So that's 90 millirems per year.
That's almost 120 millirems per year, just for living in Colorado. And that's not all.
And then, depending on the kind of structure you live in, do you live in a brick house, a wood house? Some of these things also emit radiation.
I live in a concrete building.
Okay, then let's check that box.
I get 7 millirems per year from living in the apartment building I live in, another 240 from the food I eat, liquids I drink, and air I breathe, and another millirem here and there from surprising and upsetting sources.
So your annual radiation dose, about 395.04 millirems per year. And then it breaks down your ionizing radiation exposure to the public by source. So natural sources like radon, those rocks, the cosmic radiation, over half's radon.
We didn't get a chance to say that I went to the Rocky Flats site. Would that add any?
As Carl mentioned, it would be less than 1 millirem per year, I think. So out of the 395, less than 1% change. Other exposures, medical.
I have a friend who is just finishing up his PhD in physics. They deal with low levels of radiation in the lab where he works on whatever it is he works on, and I chatted with him over the phone about this stuff to get a sense of scale from someone outside the CDPHE. He told me that his team talks about radiation in terms of banana-equivalent doses. Apparently, my favorite breakfast fruit contains a radioactive isotope of potassium. If you eat one every day for a year, as I probably do, you'll accumulate a dose of approximately 3.6 millirems. Or, in other words, you could get a larger radiation dose from eating 100 bananas than from visiting the Rocky Flats National Wildlife Refuge, according to the CDPHE. There is one other thing. In the Central Operable Unit, the land where the Rocky Flats plant actually stood, the Department of Energy does have ongoing monitoring operations, and the amount of plutonium in groundwater flowing out of the refuge has, at various times since the cleanup, required treatment. This is something that the regulators openly admit. They'll also tell you that they're working on it, and remind you that the Central Operable Unit is and will remain closed to the public even after the refuge opens. This is not some secret, but it's also not what they focus on. To the DOE, the EPA, the Fish and Wildlife Service, and the CDPHE, the story of the Rocky Flats National Wildlife Refuge is safety. Overwhelming, scientifically verified safety. As we all know well by now, this isn't the only story being told about Rocky Flats. And it's time to hear from the activists on the other side. Harvey Nichols, start us off.
The Fish and Wildlife Manager out there, David Lucas, has said to soothe everybody that the average radiation burden out there from plutonium at the refuge is no more than about 1 picocurie per gram of soil. And I thought, well, that's interesting. I better find out how I can translate a gram of soil out there into a measurement that I can understand. So I came back to my back garden, dug a 1/4 inch deep, because that is the 6 millimeter depth that they say they sample out there for plutonium, okay? So at 1/4 inch deep, I sampled enough to get a number of grams, and it turned out very conveniently that approximately 1 gram of soil at 6 millimeter depth is about 1 square centimeter. Near enough. So I then translated the 1 picocurie per square centimeter into the number of square centimeters per square kilometer. All right? Those are still picocuries. But divide that by 1,000 to get to the nanocurie level, which is still a billionth of a curie, and you're looking at approximately 10 million potentially fatal doses in a square kilometer.
After 2 years of listening and talking to the activists and their leaders, I started to mentally subdivide their arguments into 2 main categories. And they both played into that short anecdote from Harvey. Category 1, the extant contaminants, the actual stuff that's still out there. And then category 2, how do you interpret those in terms of the health risks they pose? Let's take them on in that order. First, the extant contaminants themselves. The activists present a wide range of views on this subject. Some people distrust all the government data and speculate that contamination from the fires in 57 and 69 spread as far as downtown Denver. Others allege that workers at Rocky Flats surreptitiously buried massive amounts of radioactive waste in the buffer zone that later became the wildlife refuge. The leaders of the movement, however, people like Harvey and Leroy Moore, they point to their own expert on the contamination.
You need to ask a nuclear physicist, or you could ask Michael Ketterer.
Michael Ketterer.
Michael Ketterer, yeah. At Metro State.
In case you couldn't hear that, the name Harvey said was Dr. Michael Ketterer. K-E-T.
T-E-R-E-R. I am a chemist in analytical and environmental chemistry specialties. I am professor of chemistry at Metropolitan State University of Denver.
A few weeks after I talked to Carl Spring and Lindsay Masters, I sat down with Michael in his office at Metro State.
And some of my research interests include environmental radioactivity and specifically the detection and behavior of plutonium in the environment.
Basically, he's a specialist in collecting soil samples and detecting low levels of plutonium like you'd find at Rocky Flats today.
The general procedure involves dissolving the sample to either completely dissolve it or to solubilize, dissolve the plutonium from the sample. So that involves using aggressive chemicals such as strong acids. And then the plutonium is chemically separated from the sample solution, and it can be detected by one of two means. One is called alpha spectrometry, which detects and measures the kinetic energies of the alpha decays that come from decaying atoms of plutonium in the sample. The alternative method is it's called mass spectrometry, which actually counts the atoms themselves. Those are the two main ways of measuring low-level environmental plutonium.
Michael first heard about Rocky Flats in the fall of 1980 when he moved to Colorado to begin a PhD program at CU Boulder.
I was just peripherally aware, and during that time I wasn't really studying anything about the science of Rocky Flats or the the local policy issues regarding Rocky Flats. I was not involved in that at all.
After he finished his PhD in analytical chemistry in 1985, Michael went on to work for the Gates Corporation, the EPA, and eventually as an assistant professor at Northern Arizona University. It was there, in the year 2000, when he started a new line of research and remembered Rocky Flats.
So I turned to Rocky Flats as kind of a field case study that I could use to, learn more about methodology for detecting plutonium, methodology for fingerprinting or determining the origin of the plutonium using its isotope composition.
Elements like plutonium come in a variety of isotopes, each with a different number of subatomic particles. Like plutonium-239, the weapons-grade stuff. That has one more neutron than plutonium-238. When Michael talks about plutonium having a fingerprint, he's talking about the unique ratio of plutonium isotopes in a given sample.
So the so-called isotope ratios are kind of a litmus test of where is the plutonium coming from. All you have to do is isolate the plutonium and measure it using mass spectrometry, and then you get these numbers.
It's fascinating stuff, and you can see why Rocky Flats would be a perfect place to practice this. It offers a unique fingerprint, or ratio, of weapons-grade plutonium and plutonium from the Cold War-era weapons testing.
No other motivation other
Not
than
really.
Just curiosity.
No,
and it was a
no.
great example of plutonium in the environment.
Right.
Okay.
It's one of the well-known settings in the continental U.S. that has significant non-background plutonium to be found in the local environment.
We've heard this story before, haven't we? Harvey Nichols, Ann Fennerty, Gail Biggs. Many of these leaders of the activist movement came to Rocky Flats as scientists, researched the site, and were moved to activism by what they found or experienced in that process. For Michael Ketterer, that process started with a series of soil samples. He scooped up some dirt along the edge of the refuge, took it all back to his lab, separated the plutonium, and analyzed the results.
What I found in my own work was more or less confirming what people already know, that there's a plume of elevated plutonium activities in soils, especially to the east of Rocky Flats, and that the isotope composition says very clearly that this is from Rocky Flats and is not from the global background of nuclear weapons testing.
So far, this definitely sounds like the same story, right? There is plutonium, it's off-site, it's from Rocky Flats. But here's where Michael's story starts to diverge. See, you'll notice that he has not used any adjectives to qualify the amount of off-site contamination. It's not a large amount. It's not a dangerous amount. It's not concerning. What he told me instead is that his findings were consistent with all the years of sampling and testing that preceded his work, including those tests performed by the U.S. government.
And, their findings are completely congruent with mine, or mine are completely congruent with theirs.
There have been some calls from the activists for new sampling and testing before the construction of the Jefferson County Parkway along the edge of the refuge. They talk about the 2013 floods and the wildlife and the plant life shifting the contaminants around. And Michael says he's open to doing it for them.
If I can say it this way, I don't necessarily think it's going to be it would be something that would bring surprising results. I would expect to see some redistribution, but probably on the timescale we're talking about, not a whole lot.
The activists embrace Michael. He's their plutonium guy. But he doesn't feel the same way. Not by a long shot.
I'm sort of a neutral party, you might say, to this whole endeavor. If there are people that are interested in acquiring these kinds of data, I'm willing to do that. I'm not on a campaign to say this is something that absolutely needs to be done.
I'm speculating here, but it seems to me that Michael does not feel motivated to take that next step into activism because he does not feel betrayed by the government's collective work on his area of expertise.
I do have my political opinions, and they don't really figure into the quest for the scientific truth.
So let's review. Carl Spring and the regulators say that the levels of plutonium and other contaminants in the soil at the Rocky Flats National Wildlife Refuge are very low, negligible even. Now it turns out that the activist plutonium expert doesn't dispute those levels. So on what basis do they contend that these levels are, in fact, high? That brings us to my second category, interpreting the health risks. The question of high versus low, large versus small, big versus little, is a question about health risk. Is it dangerous for a person to hike across land that has been sprinkled with plutonium? But here's the thing. There are a lot of independent scientists and former scientists affiliated with the activists, but I haven't come across a single specialist in health physics. No toxicologist either. And those are the subjects concerning health risks of radiation. The only person in the group that claims expertise in this field is the de facto leader, the 86-year-old doyen of the movement, the man who led them from the encirclement in '83 through the cleanup years all the way up to today. Leroy Moore. Okay, so let's get into some of the science. Let's get into some of the science. The science?
The science?
Yeah, of why it's unsafe.
Okay. Well, plutonium-239, the primary material that was used to construct the pit of nuclear weapons at Rocky Flats, is an alpha emitter.
Leroy is talking about ionizing radiation. Plutonium emits alpha particles, not gamma rays, not X-rays, not beta particles.
The alpha radiation is very different. It's so weak that if I had a piece of plutonium, I could hold it in my hands, and it wouldn't harm me because it only moves a short distance, and it can't penetrate skin or even a piece of paper like, a page from this book. But if I inhale plutonium, it will go somewhere in the body, and it will lodge at that location. And once it lodges there, it will stay there. And it will stay there for the rest of your life. And it will continually release alpha radiation to surrounding cells for the rest of your life. So 20 or 30 years later, a single particle of plutonium may cause cancer or, some other ailment. Or it may it may hurt your immune system, or it may be passed on to future generations. All those things are possible.
What Leroy is describing here is what I understood as the hot particle theory. It refers to the idea that a small particle of plutonium, when inhaled, ingested, or otherwise taken in by the human body, can be fatal. Remember the Colorado Department of Public Health and Environment's FAQ I mentioned earlier? They have an answer for the hot particle question.
Research has shown that a person would have to inhale large amounts of plutonium-contaminated dust particles to have a significant radiation exposure. One study concludes that, quote, based on our calculations, millions of dust particles contaminated with plutonium oxide must be inhaled in order for significant radiation doses to be delivered to key body organs and tissues, unquote. These distributions demonstrate that although it may be possible for smaller numbers of plutonium particles to induce cancer in some individuals, it is highly unlikely.
When I asked Leroy why he felt so strongly about this, he started pulling dusty old books and studies off his shelf and showing me certain passages. It was the most animated I've ever seen him. At a certain point, he started pounding on the back of one book out of sheer frustration.
The amazing thing is, well, to me, amazing, the disturbing thing, it's amazing and disturbing, is that the EPA and the Colorado Department of Health and Environment keep saying that Rocky Flats is safe. It's as if they are incapable of reading this, or of reading the National Academy of Sciences, or of reading the Columbia University scientists. They should know those things. That's their job, is to take care of the environment and the public health. But they're not doing it.
I've been reading a bit about this hot particle issue. That's what we're talking about. And I think this is where a big discrepancy is between your perspective and theirs, because I don't think it's because they're not reading. I think they just might be, they have different sources or something, because, I was just on the CDPHE's website today, and they address this question, and they cite a study from the Lovelace Respiratory Research Institute, and it said that the risk of inhaling plutonium is negligible.
Lovelace is a part of DOE's operation. It's a DOE project.
So that just delegitimizes that completely?
I guess.
Let me ask a different question, actually. Based on how much plutonium is out there right now, do you think how would you evaluate the risk of someone inhaling plutonium particle?
I think it's highly likely, because
there is a big difference between highly unlikely and highly likely. This is an impasse, and this is where most journalists stop. Most articles about Rocky Flats end right around here. He said, she said, and then that's it. 5280 Magazine, Colorado Public Radio, Westward, my own partners at the Colorado Independent. If you search their archives for Rocky Flats, you'll find dozens of stories that left me feeling, uncertain. And that uncertainty is what makes Leroy Moore's last argument so powerful. Are you sure? Are you sure?
Am I sure? I'm sure that there is a risk at Rocky Flats. I can't tell you exactly what would happen, even if you're exposed to plutonium. It varies from person to person, but there is a risk. And it would be better if we followed the precautionary principle. And wherever there's a risk, we were careful rather than careless. I think we're careless.
Even the regulators acknowledge there is some risk. A very, very tiny amount, but some. And when Leroy and the activists point to all the other beautiful parks and open spaces across Colorado and say, why this one? Why do we need to open this one? Well, I don't know about you, but I think it's pretty persuasive, especially coming from a man with the kind of gravitas Leroy has. You know his story. You know how hard he fought and for how long. He won. Not alone, but he won. The plant shut down. He was vindicated. He was right. So even if you don't think he's right this time, even if there's only a small chance he and the other activists are onto something, they've earned the benefit of the doubt, haven't they? That's why I don't blame other journalists for stopping here, for letting the conflict be the story. But I'm not done yet. I pledge to put all that history aside and look at this issue anew. And from that vantage point, I don't see a difference of opinion or perspective. I see two sides with two different sets of facts, and that's not going to work for me. After this short break and a word from one of the other members of the Denver Podcast Network, we're taking it one step further.
Coming to you from the X-Axis, it's John of All Trades with your host, John X.
Welcome to this John of All Trades podcast promo. Each Wednesday, I bring you a brand new interview with someone fascinating and ask the question we all ask when we meet someone new. Hey, what do you do? It's fun, informative, and it's the 2017 Westward Reader's Choice Award winner for Best Denver Podcast. iTunes, Stitcher, and johnofalltrades.us.
I just got off I-25 north. I am on my way to Colorado State University in Fort Collins, where I have arranged to speak with Dr. Thomas Johnson, an expert in the health effects of low-level radiation doses on humans. And hopefully, he'll have some answers for me. CSU's Department of Radiological and Health Sciences is housed in a typical bland university building. It's nondescript, except for the unsettling amount of radiation warning signs you see walking down the hallway. Even inside Dr. Johnson's office, he has a small collection of novelty items featuring that distinctive yellow and black icon. There's little cartoon figures, a smattering of other ephemera, and even a bottle of ostensibly radioactive soda. Okay. We are live now. Can you tell me what you had for breakfast this morning?
Small bowl of cereal.
Okay, sounds pretty good. That's just for sound check purposes, not...
Wasn't sure how that related to Rocky Flats, but I don't know, I don't eat radiation for breakfast or something, Maybe I'll have that radioactive soda.
Tom spent 6 years in the Navy, including almost 4 on a nuclear submarine. He's the author of a textbook called Introduction to Health Physics, and he's worked with the faculty at Fukushima University to study the radioactivity around the Fukushima Daiichi nuclear power plant after the meltdown in 2011. But most importantly for our purposes, he has never worked directly on any Rocky Flats issues.
I've certainly met people who have worked there, and we've talked to people who've done modeling and done sampling there, and they've some of them have given seminars in our program, but personally I've never done any work out there. I've driven by is as close as I've really gotten to it.
I wanted to talk to Tom because I needed a health physics expert who the activists couldn't disregard. Someone who hasn't taken Department of Energy money for a study that reinforces Department of Energy conclusions.
No, I've never done anything. Like I said, I've never even been on the site. I've driven by is as close as I've gotten.
Okay.
But I've heard multiple talks on Rocky Flats from different scientists, and they've discussed the modeling and the principles they used in order to determine the risks associated with Rocky Flats. So
okay.
Yes, I'm familiar with that part.
So just a general understanding of the situation.
Generally, yes.
Okay. So is there any reason why you'd be predisposed to, believing one side over the other, or?
There's no, believing. I would examine the facts associated with what people have done, what assumptions are made in the various models that they use to calculate risk or dose, and that's all there is to it. I mean, it is what it is when you look at the scientific models used to assert a risk factor. You can change the assumptions, certainly, and by changing the assumptions, you can have some impact on the outcomes of what you'd expect from your models. All models, I will quote someone else, all models are wrong, but some are useful. And you can make a model not useful based on your assumptions.
For about 15 minutes, we felt each other out. Before my trip, I emailed him some subjects I was hoping to cover and a few links to reports showing the levels of contamination at the refuge. I don't think I signaled to him my position one way or the other, and he certainly didn't signal anything to me either.
So, could you give me an example of that? Like of like just in general, like an assumption that would make a model useful or not useful.
Okay, if we assume that by driving 75 miles an hour, we're going to have so many car accidents per day on a stretch of road. And you might say, well, that's unacceptable. I believe my model is that there's a linear relationship. So if we cut the speed limit from 70 to 35 miles an hour, then we could cut the accident rate in half. Okay, does that make sense?
Yeah.
So then you might argue, another person might argue, well, I think that's ridiculous. We should cut it to a lower rate because that's unacceptable. We should have no deaths due to cars, so we would just eliminate cars. And you might say, well, according to your model, not only do I want to save lives, I want to create life, so we'll just make everybody drive backwards.
Huh.
Okay? So this is a misapplication of a model. All right?
Okay.
So you can say that if I said, well, if we cut the speed limit from 75 to 70, we're going to save some lives. You'd probably agree with that. But you can say driving reverse is not going to create life. Okay? It's just a perversion of a model that we were using. And does it hold true if we go down to 35 miles an hour? It's questionable. You start wondering, is this model really going to work here? And then you start looking maybe for verification of that model. How do we verify that? Can we find someplace else that maybe has done this? And this is a lot of what's happening at Rocky Flats because the risks, the doses, are mostly done through modeling because it's very difficult to make measurements of the risk there.
Okay, this is exactly what I wanted to talk about. Why is that so difficult?
It's very difficult because the doses involved are very low.
Low doses. That's a hint. I think it's time for the big question. All right, so the big problem with this site, and for a lot of the reasons that you've described, is that people like me, people like regular people, looking at this wildlife refuge, hearing about plutonium contamination, want to know, is it safe for me to visit or not? And it's really hard to get from there to understanding what the regulatory agencies are saying and even understanding what the activists are saying.
So you want the simple answer. You want the simple, easy answer? I can give it to you right away.
Well, maybe not the simple, easy answer, but like a good answer.
My answer is, I would be happy to bring my children there and have them play and ride their bicycles.
Okay,
I would be
fascinating.
Not so happy if they would go there and start snorting dirt up their nose. That would not be so good, and definitely I would stay away if it was on fire. Fire is a huge risk there because fire will kill you immediately.
When plutonium is involved?
Just fire in general.
Oh, okay.
I would stay away if it's burning.
Yeah, it does sound like a good
stay away
idea.
from burning areas, yeah.
I try my best.
That would be the highest risk, I think, out there is if it was on fire.
That sure doesn't sound like Carl Spring or Leroy Moore or anyone else I've talked to, does it? And think for a second about what this level of confidence means from someone like Tom. He has credentials. He has the weight of Colorado State University behind him. Think about what this interview represents. How little he would stand to gain from overrepresenting his certainty. Okay, so now let's talk about the distinction between the riding bikes and the snorting dirt.
Yeah, that would be in the industrial area. Do not snort the dirt in the industrial area.
Okay.
Okay. Not only is there plutonium there, but I'm not certain how the cleanup went I would advise not snorting dirt at any time, please.
Just
Do
in
not
general.
put dirt in your nose in general. This is not a good way to live your life. Okay. There's probably more hazards from the silica and other things that you would ingest or inhale that way.
Right.
So these would be bad. But the buffer zone, I would have no problems. Camping. I think it would be a beautiful place to go camping, riding bikes, things like that. It's really a great area. And because it's been protected for a while, my guess is the wildlife has really probably come back quite well. I don't have any basis for that except my experience with other locations that have been evacuated.
I went on a tour, and I could speak to some of the wildlife. I mean,
is it pretty abundant there?
Yeah, there's this herd of elk that David Lucas likes to talk about. It's cool.
Yeah, and if you think about it, based on your own experience, so you saw a herd of elk there.
Yeah.
If plutonium was so deadly, why are the elk still alive? I'm asking you.
I mean,
how come they're not all dead? Shouldn't the plutonium have killed them by now? They've been there for what? At least 10 years, which to me would seem, wouldn't that have an impact?
Well, I don't know. I don't know how long it takes for elk to develop cancer from plutonium contact. I don't know.
Well, the herd's been there for how long now? Let's just take a guess. For a while?
Since the cleanup,
but they're living there, and they are eating the grass, and their noses are pretty close to the ground. I'm guessing they might inhale a little bit of plutonium here and there, right? Because they're stirring up. They're hitting with their hooves. Remember I said the plutonium's going to stay in that upper layer because nobody wants it. So they're probably kicking it up with their hooves. They're probably inhaling that. So they're probably getting a dose of plutonium. And as I said, the kind I would recommend against, right? And yet we see a herd out there. Do we see a lot of dead elk laying around the site? I don't know. I've not been there, but did you see any when you were there?
No.
So just anecdotal evidence is not helping us here, is it?
No.
But if it really was super deadly, we would probably have some good anecdotal evidence, wouldn't we?
You hear it from people in the community. There's these activist groups. They say there's the cancer registry that the state bases their data from is erroneous. It's not good data. We're actually seeing more incidents of rare cancer in our families and neighbors.
Okay.
And that is probably connected to Rocky Flats.
So what fraction of the population... Well, let's ask you then. Do you know anybody who has cancer?
Yeah.
Okay. You probably know more than one person that's had cancer.
Yeah.
And that's because at least 1/3 of the population is going to get cancer. It's a sad fact, but it's true. And when people get cancer, was it an emotional event for them?
Certainly.
So now we've got this very emotional event, and we try to explain this. This is more of I'm no sociologist, but I know from personal experience, what do you do when you get cancer? You want to know why. Why me? Well, how did this happen? These are questions that we ask when we get sick, when we get cancer, when people in our family pass away. Why me? And radiation is there. I think it's fair to say there's not a lot that people study. I'm going to say just people outside of my profession study about radiation. So it's an unknown thing. And it's pretty easy to say radiation did it. The truth is, it's very difficult to deliver the kind of doses that it would take to cause a cancer from Rocky Flats. I mean, it can be done. Don't get me wrong. I told you, if you go in there and you go in the industrial area and you find just the right place and you just start, I don't know how you do it, but I'm certain you could find a way to do it. But then you never ask the person, hey, you wouldn't have to have been a smoker, would you? Or did you, like when I was a young child, did you clean paintbrushes with gasoline as a child and then maybe without gloves and have benzene being absorbed through your hands, which could lead to leukemia? I mean, we don't look at that. And another thing we don't look at that most of the public doesn't know is radiation can't cause all types of cancer. There are only certain types of cancer that are associated with radiation exposure. And don't worry, it gets worse from here in the uncertainty. If I give a cancer, let's say someone's got a cancer, we take it out, we give it to the world's best pathologist. They cannot tell you if it was caused by radiation. There's no certainty in that. They cannot tell you.
This is the space where the activists thrive. Uncertainty. The government created some of that with the decades of mismanagement and environmental crimes at the Rocky Flats plant. But not all of it. Some is inherent to the science. And while we're talking about the activists, I asked Tom to directly address Leroy Moore's argument about hot particles.
A hot particle would be a small chunk of material which contained a large quantity of plutonium atoms.
Okay.
In this context. There's other types of hot particles, but in this context, that's what it would be.
For the first time in our conversation, Tom seemed unsure. He stepped away from the mic, pulled out a paper and pencil, consulted some data about the levels of contamination, and then calculated the number of plutonium atoms in a gram of soil in the hottest spot recorded in the refuge.
So we got 8.1 times 10 to the 11th atoms plutonium per gram soil. Sounds like a lot.
Yeah. He then calculated exactly how many atoms are in a typical gram of soil.
So that's 2.15 times 10 to the 22nd. So the rounding error in this doesn't even incorporate that.
So it's so low as to be
It's not even in the rounding error. So
in terms of the health risks of hot particles, Tom explained that big particles of plutonium tend to get caught up in your nose hairs or mucus and exit the body before causing any damage. Slightly smaller particles make it down a little further in your respiratory tract, but the body has ways of sending those back out too.
Now, what if they go deeper yet? So we're swallowing all these particles. They're not staying in your body a long time. And if you think about it, this plutonium, it's got a long half-life, all right? Where'd I put it?
I know this one. Activists mention this all the time. Plutonium has a half-life of over 24,000 years. It's one of the reasons they say the refuge should be closed forever. It's like 24,000 years plus.
So plutonium has a half-life of 24,000 years. So if we've got one atom, the odds of it decaying while it's in there are not that high, right?
Wait, I don't understand that. So because it has a long half-life, it means...
Okay, let me ask you a different question. Let me ask you a different question. What's the half-life of lead? Infinity.
Yeah. Okay.
It doesn't decay, right?
Oh, all right.
It's stable. What's the half-life of asbestos? Infinity. It never decays. It stays asbestos forever. Okay? So now what happens as we start making that half-life just a little bit shorter? It's not infinity, but it's still pretty long. How much decaying is going on? Not a lot, right? Sorry.
Huh. Sometimes on this show, I'll use music to emphasize certain points. This time, reality did it for me. I was speechless.
You probably never thought about it that way before, did you?
It's like the exact opposite of how I've thought about it. I hear
if
from
it's got a really short half-life, like something like technetium-99 has got a 6-hour half-life. Think about that.
Okay. Yeah, that makes a lot of sense. I've been talking to people about this for I don't know, a little over a year, and people talk about the half-life of plutonium, and they just like say 24,000 years.
Yeah, it's 24,000 years. That's right.
But they say it in a way where it's like, it's a long time. That means it's going to be with us for a long time. It means it's a problem for a long time.
No, it means that atom is going to sit there. If you've got 10 atoms, it's going to take 24,000 years before 5 of them decay.
Oh, okay. Yeah.
I mean, am I right? Does that make sense?
That does make sense. Really puts that in perspective. And it, yeah, I appreciate that.
I know it's a difficult kind of thing to understand, but if it can sound really scary. You say, well, yeah, it's going to be around for 24,000 years, but half of it's going to be gone in 24,000 years. Okay. How long is lead or asbestos going to be toxic for? Or mercury? Ever. So at least we got time horizon on this one, you know? Now
that is so clear now. And yes, no, Dr. Johnson did a mind-blowing gesture, and that's how I feel.
So where were we? I'm sorry, I get sidetracked with my...
Yeah, where were we? We were almost done. Tom acknowledged that in certain very specific circumstances, a tiny piece of plutonium, a respirable particle, could get lodged in the lungs. And in those very specific circumstances, there is then a chance that the alpha radiation from that particle could cause a mutation in an adjacent cell.
Now, this is what everybody assumes always happens, is that it causes some type of mutation in the cell. That doesn't always happen. There's a probability that it could happen. This is a probability that we have a cell that is hit by an alpha particle from plutonium that causes that cell to mutate. Does that cell become cancerous? Again, maybe, maybe not. We don't know. We can't say that it happens all the time. We can only say that there's an increased probability. So the more plutonium we have there, the higher the probability we can get this to happen. It's all probabilistic.
But at the end of the day, Tom would still be willing to go out there with his kids. The probabilities are low. And this brings us back to the precautionary principle, the activist's greatest weapon.
So this goes back to the car, okay? So we got a model, and we say 75, we go to 50, we go to 35, we're going to cut it roughly in half. We go again, we're going to cut it in half again. That's the model that a lot of people will use and call it the precautionary principle, okay? So let me give you an example of what went on at Fukushima. So we're going to evacuate these people because we think they might get a dose, a radiation dose. They evacuated basically a senior center. So these hospitals, they evacuated these areas where they had some older patients. Every time you do an evacuation, what do you got to expect? And you can quantify this. You're going to have car accidents, and I guarantee there's going to be car accidents. This is very well documented. And think about the risk of moving someone from a hospital. You're transporting a patient that's already at risk. So we as a society, and we're actually working on this question, how high does the dose have to be where it exceeds the risk of moving a patient? And then we reach some other weird ethical issues like, okay, if we leave this 80-year-old patient here, they get this radiation dose. Okay, well that means they're at higher risk for what? Cancer. How long does it take between the initiating event and them getting the cancer? 20 to 30 years. Okay, so they'll get it when they're 100, 110. What do we do? These are dilemmas that I've got students working on this right now, and they're thinking these things through. We're trying to quantify it, and we're looking at what do you do when that risk is hard to measure.
This is the real conclusion to the science question. Rocky Flats is a trade-off. We could go back in and clean it up to background, But that would be dangerous for the contractors. It would compromise the wildlife refuge, and it would cost billions of taxpayer dollars that could be going to any number of other things. Bad things, yes, but also things like healthcare for the former workers at Rocky Flats, or wildlife protection programs, or something as simple as fixing a pothole. On the other hand, we could listen to people like Thomas Johnson and think about Rocky Flats in a more holistic way. Plutonium is not some unknowable menace after all, and the wildlife refuge does offer a unique outdoors experience. Here's what I'm saying. I'm saying that if there was a statewide referendum on the wildlife refuge, I would vote for it to open to the public. I'm saying that I don't think the cancers the activists point to were caused by contamination from Rocky Flats. I'm saying I'd be comfortable visiting for a hike or bike ride. I'm kind of excited to go back. I understand why others might feel differently, but after talking to Thomas Johnson and reading up on a bunch of the stuff he told me, I think the situation is clear. There's really not much else to say, is there? Is Rocky Flats safe? My answer is yes. So where does that leave us? For one, I decided to throw out my plan for a 6th chapter in this series. We've still got some bonus content to share, but there's only going to be one more main episode. And in that episode, we'll return to the school boards, the litigation, the battleground. I'm sure you've caught a few headlines or posts about what's been happening. With our new confidence about the safety of the refuge, how should we think about all that? What does it mean that the activists are winning? And what's being lost in the fight? Next time on Unclear Danger, the future of Rocky Flats. Changing Denver is a proud member of the Denver Podcast Network. In the shadow of the mountains,
we speak.
Unclear Danger, the Colorado story of Rocky Flats, is being produced in partnership with the Colorado Independent and the Denver Public Library. Changing Denver is supported by listeners like you, and your support is more important than ever, especially after this episode. I am sure that we're going to be losing listeners. So go right now and set up a monthly pledge on Patreon. That's patreon.com/changingdenver. patreon.com/changingdenver. Special thanks this time to our super agent backers, Mark Maringer, Jason Peterson, Jeff Reisig, Joel Noble, Mark Roxwald, and one anonymous donor. Thanks also to Carl Spring, Lindsay Masters, Michael Ketterer, Harvey Nichols, Leroy Moore, Thomas Johnson, Susan Green and Tina Griego of the Colorado Independent, Jenny LaPerriere of the Denver Public Library, and Megan Ariano. Our theme song is Minnow by Felix Fast4ward. The other music in this episode is by Soft and Furious, Chris Zabriskie, and Aethernaut. We have links to all their work on our website, changingdenver.com. Follow us on Twitter for updates about Rocky Flats, @ChangingDenver. Chapter 5 is coming soon, but we've got a few more surprises in store before it's ready for you. Until then, I'm your host, Paul Caroli.